Okay, what we're talking about today is lesson 79, understanding piecewise functions. A piecewise function is a function comprised of at least two functions. Each function defines a different part of the function's domain. Okay. Example 1 says graphing a piecewise function. The information in the table shows the admission prices to a local museum. Graph the piecewise function showing the museum admission costs for someone X years of age. Okay. So they give us that if you're under 12, it's $5, 12 to 50 is $12, and over 50 is $10. So this is my X, this is my Y, and I'm going to create a graph based on this information. Okay, so age goes down here, and price is over here, and I know my price ranges from 5 to 12, so we're going to go 2, 4, 6, 8, 10, 12, 14, 16, and 20. Okay, so for the age, it ranges from basically 0 to 12, or 0 to 50. So we'll go 10, 20, 30, 40, 50, and 60. So if you're under 12, ages under 12 would be if you were 0 to 11 years old. Okay, so it's going to be just over this 10. Okay, and that's $5, which is going to be right here, and it's from 0 to 12. Okay, or to 11. We'll go to 12. But it's not going to include 12, so it's going to be open. Because at 12 years old, it costs $12. So at 12, we'll go up to 2, 4, 6, 8, 10, 12, this one. And it's going to include 12 years old. And from 12 to 50, so from there over to here. And it includes 50 because it says 12 through 50. Okay, is $12. And then our last one is if you're over 50, so that's $10. So we're going to go down just a little bit to the $10 mark. It's going to be open, and it continues on in that direction. Okay, and we should show an arrow because this would look like about 80, and it doesn't say that you can't come to the museum if you're over 80, so it's including any age after 50 years old. A step function is a piecewise function that is constant for each interval in its domain. The graph of the museum admission prices is a step function. Notice that the step function passes the vertical line test. Piecewise functions have all the attributes of a function. To evaluate a function for a given value of x, find the domain interval to which x belongs. Then find the corresponding range values. So, it says evaluate the piecewise function for x is 0 and x is 5. When x is 0, okay, we have to see which part of it falls into. Okay, so if x is 0, this is if x is less than 0, so it wouldn't be that one. This is if x is 0 is less than or equal to x. So if x is 0, then f of x is -5. And whenever x is 5, equal to 5, this is if x is less than 5. X is equal to or greater than 5 here. So when x is equal to 5, f of x is equal to that too. Okay? So that's it. Which in this case we could plug in our 0 here and our 5 here. So f of 0 is -5, f of 5 is 2. Example 3 says write a piecewise function rule for the graph. We have to look at this and see what we know here. So first of all, we know that we are including 0 in this, and it's going over to 2, but it doesn't include 2. So this is going to be that this part right here is that 0 is less than or equal to x, which is less than 2, but not equal to 2. Okay? The next part includes 2 and goes over to 4, but does not include 4. Okay, so this one is telling us that 2 is less than or equal to, because it's shaded in, x, which is less than or equal, not equal to, just less than, which is less than 4. Okay, so that's the range there. And here we're at 4, and we go over to 6. It's going to be the same thing. 4 is less than or equal to x, which is less than 6. So in this one, we have f of x is, and then each of those three things. We have 0, well, we also have to have our y value here. So we have 2 for 0 is less than or equal to x, which is less than 2. Then we have that it's at 4 when 2 is less than or equal to x, which is less than 4. And then the last one is at 6 when 4 is less than or equal to x, which is less than 6. Final answer. On example 4, it wants us to graph the function for f of x. Okay. Whenever we want to graph these, we have to come up with a table to help us do that so that we don't make a mistake. So since the first one that is talking about x is less than -1, a number less than -1 would be -2. So I'm going to have, I'm going to go from -2, and I'm going to go down to where x is greater than or equal to 2. So I'm going to include 2 and numbers greater than that. In this case, they decided to go -2, -1, 0, 2, 3, 4, and 5. Okay. And then we have to include all three of these because it depends on where it falls, right? So the first function is 2x plus 1. The next one is -3x. The next one is x squared minus 10. Okay. This is my table of values. So when x is -2, that falls here. So if I plug in -2, I get -2 plus 1 gives me a -3. If x is -1, that one falls, this one will go up to that one. Okay, so we can plug that in here and we have 2 times -1 is -2 plus 1 is -1. Then we can plug it into this one because this is where -1 is also. So we have -3 times -1 is just a +3. Okay. For 0, 0 also falls in this range. So we're going to plug in 0 here. We get 0. And 2 falls here. So if I plug in 2, I have -3x times 2, or -3x. -3 times 2 is -6. Then 3 falls in the last one, okay, because it's x is greater than 2. So 3 squared is 9, minus 10 is -1. 4 squared, 16, minus 10 is 6. 5 squared is 25, minus 10 is 15. Okay, then all we have to do is graph that information. We know that we have -2, -3. Okay, these are our x's and these are our y's. -2, -3 is going to be -2, 1, 2, 3. Okay, and that one was included. This one, the -1, was not, because where it's less than -1, this would be equal. Okay, so we have -1, -1, which is about here, but it's going to be an open circle. Okay, and it's going to go through that point. So roughly like that. Okay. The next one is -1, 3. That's where it's going to be filled. So 1, 2, 3, because that's where -1 actually falls in this area. And then we have 0, 0, And then we have negative 2, or not negative 2, 2, negative 6. So over 2, 1, 2, 3, 4, 5, 6. Okay. So if we go through those points. And then we have 3, negative 1. So over 3, down 1. 4, 6. Over 4, up 6. And then the last one is over 5 up 15, which is somewhere up here. So we're just going to take from that point here, and it's going like that. So that is what our graph should look like. Okay, we have this open circle here because negative 1, that is actually not part of the solution. It just gets to negative 1 because this one was for where x is less than negative 1. Not where it's equal to. Where it was equal to negative 1 was this one, which is where we got the 3 from. Last example. Example 5 says United States Postal Service insurance rates for up to $500 of coverage are shown below. Write and graph a piecewise function for the cost of X dollars of insurance coverage. Okay? So what you have to look at here is you have to come up with your functions. Okay, so the fee is $1.65 for up to $50. Okay, so that means that where X is less than or equal to $50, it's that $1.65. Then for the next one, it's $2.05, where it's 50.01 is less than or equal to X, which is less than or equal to 100. And 245 is going to be where 101 is less than or equal to X, which is less than or equal to 200. And this is going to continue the exact same way all the way through. Okay, and as far as making the graph for this, I really don't want to because it's going to be a huge pain. But just know that it has to be filled. You'll have it filled over to open, and then it'll step up a little bit, filled over, open, whoops, open, step up a little bit, fill it over, open. Not easy to do with my tablet, so you can look in your textbook on page 560 and see what that graph looks like. Okay, that is all I have for you today for your homework. We're going to do lesson 79, A through E, and (5 through 25 odd). Okay, so A through E, 5 through 25 odd. It'll be due when you come into the room on Monday. On Monday, you'll do your final textbook assignment, and then you'll have a couple days to review before you take your test. That is all I have for you. I hope you have a good rest of the day.